in the name of Jesus. Every knee must bow. When we pray in the name of Jesus, every knee must bow. When we pray in the name of Jesus, every knee must bow. When we pray in the name of Jesus, every knee must bow. Hey, your name is a strong tower. Jesus, to you belong, to you belong, God. To you belong, Jesus. Whenever I call you, whenever I call you, make a way. Your name is a strong tower. Jesus, your name is a strong tower.
Our colleagues and students online. Today is another great day. Today is the 2nd of June 2023, and we are happy to the Department of Chemical Sciences, who is currently in the UK, who is joining the defense online. We have the supervisors here. We have the main supervisor, Professor Engineer Nana Safu Ajima. Yes, am I correct? I think my memory of the name is correct now. Very good. So then we have the HOD, Head of the Department, Dr. Prince N.G. with us here. But then we have the co-supervisor, Dr. Cynthia La, from the Council for Scientific and Industrial Research, also here, online. In Ghana. But she's joining online. Ghana Atomic Energy. Okay. Then we have Professor Ronin Fraser William from
University of Sierra Leone,
University of Sierra Leone, Forabe College. Also joining online.
Yeah.
Very good. So, gentlemen, we are welcome this morning to this important session of a PhD defense of our brother. He initially wanted to do that online, and I said that is not very favorable to us. We want him to come here and display his skills to us. Let's see how his body language will perform during the question and answer time, and how he will present to us. So he's here. He's a very lively person, and I believe he's going to give us a very good presentation and a defense. So without much ado, we welcome our brother AZIZ SANKOH from Sierra Leone to give us the presentation. We are giving you 40 minutes to present, and then
45.
Yeah, 40 minutes.
Initially said 45.
45, okay, 45 minutes to present. Thereafter we proceed with the examination. Your friends are here from Cameroon, they are also watching. They are going to see how you go to defend. But their thesis is also almost there. Next week they will defend. And so they are going to learn from you. Make sure you perform. Thank you very much. Let's see how it goes.
I am AZIZ SANKOH. Today, I'm here to present my PhD thesis on the topic application of the spatial and spatial isotopic model to determine groundwater pollution sources around some of the Sierra Leone. This is a list of my presentation outline. I will first of all give a brief discuss on the background of the study, and I will state the problem of the study, and I also outline the research objectives. I will prefer a brief overview of the isotope methods utilized, and I will give a brief discussion.
Hello. Our professors online and our students online. Can we hear the presentation? Is that it? Okay. He'll get close to the machine. Yes, okay. Thank you very much. I think he'll get that. I will also minimize mute mouth.
Welcome everyone. Good morning. I am AZIZ SANKOH. I'm a PhD candidate in the Department of Civil and Environmental Engineering. Today I'm here to present my PhD thesis on the topic application of geospatial and initial isotopicity model to assess groundwater pollution around the very good and the Kingston site in South Sierra Leone. So this is the list of my presentation outline, which starts from introduction to acknowledgement. And first of all, give a brief background on the study that I undertook, and also state the problems of the study, and also outline the research objectives, and provide a brief overview of the isotope methods, give a brief discussion on the study area and study methodology utilized, discuss the important results, and provide conclusions and recommendations, and state the limitations of the study, its contribution to knowledge, and display the selected list of references and acknowledgement. Corporate disclosure has been a significant issue, especially in developing countries. According to Allen et al., in 2015, nearly 9 million people die each year owing to diseases linked to dump-site pollutants. The major issue of dump-site pollutants is the production of leachate. Leachate is actually a thick, solid liquid, toxic liquid, which contains heavy metals and other toxic materials. And one of the detrimental effects of leachate is its induction of nitrate, fluoride, chloride, salinity, and heavy metals. So nitrate contamination of groundwater has been a major environmental crisis, as its consumption can induce blue-grade syndrome, and also toxicological studies have also demonstrated that fluoride can induce dental fluorosis, and heavy metals such as cadmium, magnesium, lead will also induce kidney disease. So this particular, the following mortality rate gave me the motivation to undertake this project, that is to assess the groundwater pollution around dump sites. The problem we are analyzing. And with a PhD, there is a lack of engineered landfills, which are environmentally friendly. So the only dump sites utilized are the gravity group and the Kingston dump sites. They do not contain seals, but liners. So therefore, the leachate mix it with poor sewages and percolate it to the groundwater bodies, thus causes pollution. So as a result, lots of other health consequences emerge, such as cholera and diarrhea. Despite the dump site leachate, a lot of other polluting sources exist in the dump site, such as we have the pit latrine, we have the sewage, we have the pesticides, we have the pig manure and fertilizers. So, however, only few studies have taken place to work on this issue. But the only study that we have undertaken was the geochemical study done by February and Isletal in 2002. The major limitation of these studies is that they were not able to determine the sources of the pollutant. Because if they had been able to determine the sources of the pollutant, they would have been able to prevent the contamination from the source. Because the major strategic way to manage groundwater sources is to prevent the pollution from its source. So that's the major issue I'm coming to solve. That is to integrate the multivariate and the statistical technique alongside the geospatial technique to determine the sources of groundwater within the ground and the Kingston dump site. So these are my research objectives. So the aim of the study is generally to assess groundwater pollution around the ground and the Kingston dump site with three major objectives. One, to determine the extent of pollution, the degree of how the water has been polluted. Secondly, to determine the origin of the groundwater and the sources of the dissolved ions. And lastly, to determine the sources of the nitrate, because the nitrates have been extremely detrimental to human health, especially to inference. So I need to determine the sources of the nitrates and with fast solution to how to stop these nitrates contamination of groundwater. This is the overview of the isotope methods. First of all, there are a lot of scientists here, or a lot of physicists who may not have much concept on the isotope techniques. So I would like to just go for a brief overview of isotopes. So isotopes are atoms of elements that basically have the same atomic number but different mass numbers. So hence we have different neutron numbers. So as you can see, this is the isotope of hydrogen. So all the atomic numbers are 111 and the mass numbers are 1, 2, and 3. So hence they have different neutron numbers. So isotopes will be stable or unstable. It depends on the proton to neutron ratio. So if you look at the plot of the neutron to the proton ratio, where we have the dark line where we have the dark line is what we call the band of stability. So all the neutrons and protons, the atoms that falls within this are regarded as unstable. So anyone that falls deviated from it is regarded as unstable. So it all depends on the neutron to proton ratio. In my research, I utilize the stable isotopes of hydrogen, deuterium, and nitrogen, and oxygen to determine the sources of collision within the study area. So how do we determine the sources of collision? The sources of, first of all, the origin of groundwater and the dissolved ions. Firstly, water basically preserves the isotopic fingerprint, except when mixed with sources of the fast isotopic techniques. What do I mean? If we have the precipitation, all of the precipitation in the world will have the same deuterium and oxygen 18 values, except if they mix with other sources that have different deuterium and oxygen 18 values. So therefore, all the water that are from precipitation will form what we regard as the global meteoric water line. This is the global meteoric water line. So if the water originates from precipitation, it must fall within this line. But if a particular water source deviates from this, definitely it's either from seawater or anthropogenic activities. Now, why do I say from seawater in this case? When there is seawater, we are going to have high evaporation. So due to high evaporation, the oxygen 18 will be highly enriched more than the deuterium. So because it is highly enriched, it is going to deviate, it is going to fall below the global meteoric water line, which is proposed by Cree in 1961. However, when there is anthropogenic activities going on, there is going, like for instance, methanogenic process. You know, methanogenesis is the process of forming the methane gas. So they are only going to have a CH4, no oxygen. So because of that, the deuterium in that CH4 is going to be highly enriched. So here, the deuterium, if we have anthropogenic activity going on, the deuterium is going to be highly enriched than the oxygen 18. So therefore, if water is contacted or has been contacted by any anthropogenic activities, then it is going to fall above the global meteoric water line. So this is a clear indication to demonstrate how the dissolved ions and the origin of groundwater would be diversified. So this is one of the papers that we published. It's a review paper on the previous distance I have just given. So let's go to the study area. The study was basically undertaken in Freetown, Sierra Leone. Sierra Leone is located in West Africa. So the study area basically housed a population of 1.4 million people. That was in 2006. The size of the Gambia Freetown site is more larger than that of the Kingston. The Gambia Freetown site has an area of 14.96 acres, whilst the Kingston site covers an area of 14.554 acres. The geology of the study area is comprised of a mesozoic fracture which was drastic igneous rock, and also a fracturous Freetown Peninsula complex. So this is the study area. So this is the Gambia Freetown site, and this is the Kingston site. So this area boundary is the ground site. Why is these are the position of the groundwater point, sampling point? So this is the sampling and the storage. how were the samples collected? Several different samples were collected, which are like wastewater, the sewage, the groundwater, soil samples, and the likes. So the sample duration spanned from January 2020 to June 2022. The method utilized was the systematic sampling method. Before the groundwater was collected, the wells were well cut for 5 minutes to prevent stagnated water. So the low flow method was utilized. For the surface water, a big sampler was used to collect the surface water with a depth of 3 to 4 feet. While for the rainwater, the main tank was utilized. A plastic layer was used to collect the groundwater, and a syringe was used to collect the wastewater, which has a 0.25 micrometer cellulose filter paper within it. And four water samples were collected at each sample point. Why? Because I have to do analysis for chemical parameters, isotope, which is the deuterium and the oxygen-18, the nitrate, that is the N15, and they are going into different labs. So that is why I collected 4 samples in each sample point. For the soil samples, a hand auger, as we demonstrated in this floor, was utilized, and it was collected at a depth of 46 meters. After all the water samples have been collected, they will be filtered with 0.45 micrometer cellulose filter, so you look with suspended solids. The cation, all the samples for the cations analysis were conditioned with 65% nitric acid. Whilst the handheld global positioning system, which is the GPS, was used to determine the locations of each sampling point, so that it could be marked in the map. Then, with regards to the storage, all the water for all the samples for the CS metal and major ions were stored in 500 high density polyethylene bottle. Whilst the ones for the isotopic analysis were stored in the 30 high density polyethylene bottle. For the soil samples, they were stored in a Ziploc bag. All of the samples were stored at 4 degrees Celsius before taken to the lab for analysis. So this is the lab analysis for objective 1. Let me draw your attention. Objective 1 is to determine the extent of groundwater pollution within the study area. For both the chemical parameters were analyzed. For the pH, physical parameters, the pH, electrical conductivity, the TDS, the temperature, and the salinity were analyzed at in situ, that is at the study area. And they were analyzed using the electric. Welcome everyone. Good morning. I am AZIZ SANKOH. A PhD candidate in the Department of Civil and Environmental Engineering. Today I'm here to present my PhD thesis on the topic of application of geospatial and initial isotopic model to assess groundwater pollution around the very good and the Clinton Dome site in South Sierra Leone. So this is the list of my presentation outline, which starts from the introduction to acknowledgement, and first of all give a brief background on the study that I undertook, and also state the problems of the study, and also outline the research objectives, and provide a brief overview of the isotope methods, give a brief discussion on the study area and study methodology utilized, discuss the important results, and provide conclusions and recommendations, and state the limitations of the study, its contribution to knowledge, and display the selected list of references and acknowledgement. Proper rate disposal has been a significant issue, especially in developing countries. According to Allen et al., in 2015, nearly 9 million people die each year owing to diseases linked to dome-site pollutants. The major issue of dome-site pollutants is the production of leachate. Leachate is actually a thick, solid liquid, toxic liquid, which contains heavy metals and other toxic materials. And one of the detrimental effects of leachate is its induction of nitrate, fluoride, chloride, salinity, and heavy metals. So nitrate contamination of groundwater has been a major environmental crisis, as its consumption can induce blue-grade syndrome, and also toxicological studies have also demonstrated that fluoride can induce dental fluorosis, and heavy metals such as cadmium, magnesium, lead will also induce kidney disease. So this particular, the following mortality rate gave me the motivation to undertake this project, that is to assess the groundwater pollution around dump site. The problem statement. In Peter, there is a lack of engineered landfills, which are environmentally friendly. So the only dump sites utilized are the gravity group and the Clinton dump sites. They do not contain seals, not liners. So therefore, the leachate mix it with water sewages and percolate it to the groundwater bodies, thus causes pollution. So as a result, lots of other health consequences emerge, such as cholera and diarrhea. Despite the dump site leachate, a lot of other polluting sources exist in the dump site, such as we have the pit latrine, we have the sewage, we have the pesticides, we have the pig manure and fertilizers. So, however, only few studies have taken place to work on this issue. But the only study that we have undertaken was the geochemical study done by February and Isletal in 2002. The major limitation of these studies is that they were not able to determine the sources of the pollutant. Because if they had been able to determine the sources of the pollutant, they would have been able to prevent the contamination from the source. Because the measures that we take to manage groundwater sources is to prevent the pollution from the source. So that's the major issue I'm coming to solve. That is to integrate the multivariate and the statistical technique alongside the geospatial technique to determine the sources of groundwater within the ground and the Clinton dump site. So these are my research objectives. So the aim of the study is generally to assess groundwater pollution around the ground and the Clinton dump site with three major objectives. One, to determine the extent of pollution, the degree of how the water has been polluted. Secondly, to determine the origin of the groundwater and the sources of the dissolved ions. And lastly, to determine the sources of the nitrate, because the nitrates have been extremely detrimental to human health, especially to infants. So I need to determine the sources of the nitrate so I will go fast solution to how to stop these nitrates and contamination of groundwater. This is the overview of the isotope methods. First of all, there are a lot of probably non-scientists here, or a lot of engineers who may not have much concept on the isotope techniques. So I would like to just go for a brief overview of isotopes. So isotopes are atoms of elements that basically have the same atomic number but different mass numbers. So hence we have different neutron numbers. So as you can see, this is the isotope of hydrogen. So all the atomic numbers are 111 and the mass numbers are 1, 2, and 3. So hence they have different neutron numbers. So isotopes will be stable or unstable. It depends on the proton to neutron ratio. So if you look at the plot of the neutron to the proton ratio, where we have the dark line where we have the dark line is what we call the band of stability. So all the neutrons to proton, the atoms that falls within this are regarded as unstable. So anyone that falls deviated from it is regarded as unstable. So it all depends on the neutron to proton ratio. In my research, I utilize the stable isotopes of hydrogen, deuterium, and nitrogen, of hydrogen and nitrogen and oxygen to determine the sources of pollution within the study area. So how do we determine the sources of pollution? The sources of, first of all, the origin of groundwater and the dissolved ions. Firstly, water basically preserves the isotopic fingerprint, except when mixed with sources of the fast isotopic techniques. What do I mean? If we have the precipitation, all of the precipitation in the world will have the same deuterium and oxygen 18 values, except if they mix with other sources that have different deuterium and oxygen 18 values. So therefore, all the water that are from precipitation will form what we regard as the global meteoric water line. This is the global meteoric water line. So if the water originates from precipitation, it must fall within this line. But if a particular water source deviates from this, definitely it's either from seawater or from anthropogenic activity. Now, why do I say from seawater in this case? When there is seawater, we are going to have high evaporation. So due to high evaporation, the oxygen 18 will increase more, will be highly enriched more than the deuterium. So because it is highly enriched, it is going to deviate, it's going to fall below the global deuterium borderline, which is proposed by Cree in 1961. However, when there is anthropogenic activity going on, there is going, like for instance, metallogenic process. You know, metallogenesis is the process of forming the methane gas. So they are only going to have a CH4, no oxygen. So because of that, the deuterium in that CH4 is going to be highly enriched. So here, the deuterium, if we have anthropogenic activity going on, the deuterium is going to be highly enriched than the oxygen 18. So therefore, if water is contacted or has been contacted by any anthropogenic activities, then it is going to fall above the global deuterium borderline. So this is a clear indication to demonstrate how the dissolved ions and the origin of groundwater would be diversified. So this is one of the papers that we published. It's a review paper on the previous distance I have just given. So let's go to the study area. The study was basically undertaken in Freetown, Sierra Leone. Sierra Leone is located in West Africa. So the study area basically housed a population of 1.4 million people. That was in 2006. The size of the Gambling Woodland site is more larger than that of the Kingston. The Gambling Woodland site has an area of 14.96 acres, whilst the Kingston site covers an area of 14.554 acres. The geology of the study area is comprised of a mesozoic fracture which was classic igneous rock, which is also a fractural scale Freetown Peninsula complex. So this is the study area. So this is the Gambling Woodland site, and this is the Kingston site. So this area boundary is the dump site. Why is these are the origin of the groundwater point, sampling point? So this is the sampling and the storage. How we have the samples collected? Several different samples were collected, which are like wastewater, the sewage, the groundwater, soil samples, and the likes. So the sample duration span from January 2020 to June 2022. The method utilized was the systematic sampling method. Before the groundwater was collected, the wells were well cut for 5 minutes to prevent stagnated water. So the low flow method was utilized. For the surface water, the deep sampler was used to collect the surface water with a depth of 3 to 4 feet. Whilst for the rainwater, the main lane was utilized. A plastic layer was used to collect the groundwater. And a syringe was used to collect the wastewater, which has a 0.25 micrometer cellulose filter paper unit. And four water samples were collected at each sample point. Why? Because I have to do analysis for chemical parameters, isotope, which is the deuterium and the oxygen 18, the nitrate, that is the N15, and they are going into different labs. So that is why I collected 4 samples in each sample point. For the soil samples, a hand hopper, as demonstrated in this video, was utilized, and it was collected at a depth of 46 meters. After all the water samples have been collected, they will be filtered with 0.45 micrometer cellulose filter to remove the suspended solids. The cation, all the samples for the cations analysis were conditioned with 65% nitric acid. Whilst the handheld global positioning system, which is the GPS, was used to determine the locations of each sampling point so that it could be marked in the map. Then, with regards to the storage, all the water for all the samples for the CS metal and major ions were stored in final level high density polyethylene bottles. Whilst the ones for the isotopic analysis were stored in the 30 ml high density polyethylene bottle. For the soil samples, they were stored in a Ziploc bag. All of the samples were stored at 40 degrees Celsius before taken to the lab for analysis. So this is the lab analysis for objective 1. Let me draw your attention. Objective 1 is to determine the extent of groundwater pollution within the study area. For both the chemical parameters were analyzed. For the pH, electrical, physical physical parameters, the pH, the electrical conductivity, the thickness, the temperature, and the salinity were analyzed at in situ, that is at the study area. And they were analyzed using the electrochemical method and using the WTW multimeter. While for the bicarbonate, it was also analyzed at in situ using the cytometric method. So for the chemical parameters, we have two different types. We have the trace ion, which are the heavy metals, and we also have the major ions. For the trace ions, we have the copper, the chromium, the zinc, the iron, the manganese, and the lead. We are analyzed using the AAS, atomic absorption spectrometer. While for the major ions, the fluoride, the nitrate, the sulfate, and phosphate, we are analyzed using the ion chromatography, we use the chromatographic method. So after all the analysis have been done, I try to validate the R sample over the R smooth. So this R sample is the ratio of the heavier isotope over the lighter isotope, whilst the RV of the sample tries to determine the percent difference of the cations and the anion. So previous studies have demonstrated have shown that the criteria for the perfect percent difference should be between the plus or minus 5%. However, other studies have also shown that the plus 10 or plus or minus 10% will be tolerated. However, all the samples that falls within the plus 10 or minus 10% difference for my analysis were used for the data analysis, whilst those that were above or deviate from it were described. So this is my first activity, that is to determine water quality, determine the extent of water quality. So the water quality index was used to determine the extent of groundwater pollution within the study area. One may want to ask, what is water quality index? First of all, if you tell a non-scientist that the bicarbonate and pH of the water is high, it could be very difficult for that person to comprehend that particular statement or show whether that water is good for drinking purpose or not. So therefore, the WPI incorporates all the physiochemical and microbiological parameters, if possible, to give just one unit. That is to show whether the water is good or excellent or poor for drinking purposes. So several water quality indexes have been established. The first water quality index was the WPI, which was established by Continental in 1965. So subsequently after its inception, Hackerson 1980 also established the degree of contamination. All of these ones have the same concept, it's just that they have different formulas that we are using. Now, when we look at this water quality index, this is the formula that we are using. The CV, this is the formula, the OIP, this is the formula, and this is the heavy metal evaluation index. This is used to determine the extent of heavy metals in the study area, how the heavy metals have impacted the groundwater in the study areas. Now, when you calculate the WPI, if the value is less than 50, the water will be classed as excellent. If it is between 50 to 100, it will be classed as good. So this will give a clear indication to even non-scientists that the water is good or slightly polluted or very poor for drinking purposes. So this is the role of the water quality index. So to draw your attention, 13 water quality parameters we are incorporated into the model. So let's go to the special assessment of the groundwater. It is very impossible for me to determine all the groundwater pollution within a particular study area. So what I did was, I used the systematic sampling method to determine the water quality at a specific interval. So after that, I used the special interpolation techniques to find values for on-sample sites. So even if I have not done any analysis in a specific site, but the geospatial technique will be able to infer or predict values for that particular on-sample site. So that is the role of the geospatial technique, that is to predict value of analyze at on-sample site. So several geospatial techniques have also been established, such as the inverse distance reading method, the ordinary reading, the co-reading, and the screen method. However, literature have demonstrated that the inverse distance reading method and the ordinary reading have been widely used for groundwater and studies. However, my study basically utilized the inverse distance reading method. Why? Because it is extremely simple to carry on rather than the ordinary reading. The ordinary reading involves some preliminary models, which will be difficult for non-geologists. So this is the formula for the IDW. So the key thing is to determine the unknown method value for the point J. which will be used in this formula. So after the IDW interpolation has been done, I have to assess my model, whether it is good or not. So I utilize the root square error technique to determine the model. So if the root square is lower, is small, then the model is good. If it is higher, probably more than 10%, then the model will be regarded as at least as very poor. So that is the special technique. So this is the lab analysis for objective 2. What is objective 2? To determine the origin of groundwater around the dump site and as well as dissolved ions. Because if we could be able to determine the dissolved ion, then we will be able to know the sources of the collision. Now, the deuterium and the oxygen for both the origin of groundwater and the sources of the dissolved ions, the deuterium and the oxygen were utilized. How? So for the oxygen and deuterium, 1 million electrons of the sample was added to 6 years and we are measured sequential using the oxygen vector. So the liquid water isotope analyzer was used to determine the deuterium and oxygen of the water samples collected. Now, the analytic precision of the O18 was within 0.2%, while the deuterium was 1.0%. The oxygen and deuterium value is expressed in the delta per mole value. That is the R sample over the RV smoke. So this R sample is the ratio of the heavier isotope over the lighter isotope, whilst the RV of the sample, whilst the RV smoke is the ratio of the heavier isotope over the lighter isotope of the standard, which is the V smoke. So my next activity under this objective is to determine the proportional sources of groundwater recharge and dissolved ions. I want to also draw your attention that these two sub-activities, which are the origin of groundwater and sources of dissolved ions, will just qualitatively determine the sources of the water. Okay, this water is coming from precipitation, this is coming from seawater, right? But these proportional sources of groundwater recharge and dissolved ions will determine how much of the seawater has recharged the groundwater, or how much of precipitation recharged the surface water. So it will give us a quantitative overview of the process. So in doing that, I utilize what we call the Bayesian isotopicity model. And under the Bayesian isotopicity model, we have several types of isotope data. We have the stable isotopicity model in R. We have the stable isotope, we have the mixed R, and we have the mixed R. So in this case, I utilize the stable isotopicity model in R because it is one of the latest utilized isotope model used for groundwater storage. So this is the model. So this is the third objective, that is to identify and determine the sources of nitrate pollution. As I said earlier, nitrates are extremely detrimental to human health. So here I use the O18 nitrate and the N15 nitrate to determine the sources of nitrate, which I will discuss in detail. So here the bacterial denaturation method was used, where this involves the reduction of the nitrate to the nitrous oxide using a denitrified bacteria. The extraction was done online using an auto sampler, and the measurement was done using the isotope ratio mass spectrophotometer. Also here, I try to not just determine the source of the nitrate qualitatively, but to also determine the source of the nitrate quantitatively. So I utilize also the Bayesian isotopicity model that I don't discuss. I noticed I was too fast. I missed out on something on this one. Now, how was the application of N15 and the O18 to identify nitrate pollution sources utilized? This is very important for my research. Now, when you look, before you know how this N15 and the O18 will be used to determine nitrate pollution sources, you first of all have to understand what are the various sources of nitrate. These are the various sources of nitrate. You have the dump-site leachate, domestic wastewater, animal manure, septic waste, inorganic fertilizers, the NPK, which is used in Africa most often, the soil nitrogen, and the atmospheric nitrate. Now, these dump-site leachate and domestic wastewater always undergo the process of denitrification. What is denitrification? This is the removal, this is the reduction of nitrogen to other forms of nitrogen, such as nitrous oxide or nitrogen. So in this case, during denitrification, what happens? The N15 of this dump-site leachate and domestic wastewater will increase. That is, it will be the equivalent of +10 to plus 25. Why is the O18 going to analysis such as the boron carbon and the tritium? Also, when you take into consideration of the nitrate concentration rather than the isotope, since heteroscific denitrification moves and it involves the reduction of the nitrate to nitrogen, what happens? This nitrate concentration of the nitrate will reduce in the product acid. So in that case, the bicarbonate will increase. So when denitrification occurs, we are going to have high N15 and high O18 coupled with low nitrate. So this is one of the simplest ways to determine that heterotrophic denitrification of the product. And when you know that heterotrophic denitrification of the product, what causes heterotrophic denitrification? The sources of the nitrate will be on-site leachate and domestic wastewater. So this is key. The other thing that you have to take into consideration is the ammonia volatilization. Animal manure and septic waste cause ammonia volatilization because it contains urine. So ammonia volatilization is a process by which the urea that contains urine is reduced to the nitrate. It's oxidized to the nitrate. So in this case, what happens? The N15 is going to increase, it's going to be enriched, it's going to be between plus 10 to plus 25. And the O18 is going to be between plus 10 to plus 12. So the difference between denitrification and ammonia volatilization is the concentration of the nitrate. So for ammonia volatilization, since the product is nitrate, then we are going to have high nitrate when ammonia volatilization occurs. So if you have high N15 and O18, and at the same time you have high nitrate, then you infer that ammonia volatilization has occurred. What causes ammonia volatilization? Animal manure and septic waste. Let's go to the nitrification process. So nitrification basically involves the oxidation of the nitrous oxide to nitrate. Why is the O18 be between plus 10 to plus 12? So it could be the N15 will be very significant to differentiate between nitrification and denitrification and that of ammonia volatilization. So since also nitrate is within the product part, the nitrification also is going to have high nitrate concentration. So when there is inorganic fertilizer or NPK or soil nitrogen present in a water sample or causes or triggers the nitrate concentration, then we are going to have a nitrification process. And you have to also understand that the nitrification process takes place in an oxy environment that has enough oxygen. So because of that, dissolved oxygen is also going to increase. While for the denitrification, it is going to take place in an anoxic environment. So the dissolved oxygen is going to decrease significantly. So if you have high dissolved oxygen in the water sample analyzed, you know that that particular water has not by any way been contaminated by non-site leachate nor domestic wastewater. So I saw you'll be able to appreciate how the N15 and the O18 will be utilized to determine the different sources of nitrate pollution in groundwater. So let's go. So now let's go to results and discussion. Let me draw your attention for objective 1 is to determine the extent of groundwater pollution within the study area where the water quality index was utilized. So here, you find out that in the dry season for both the Grammy and Keaton sites, the majority of the dry season, 60.7% of the water were excellent, while 50% were excellent for the rainy season. So this simply implies that the water was more better in the rainy season than the dry season. This might be due to the dilution effect. So that is what is happening. So you also find out that from the spatial distribution now, the majority of the wells that are very close to the Grammy site have high water quality index. This might be due to the impact of the leachate or the dump site. So while for the Keaton dump site, you find out that the majority of the water are excellent and good. 80% are good and excellent. So that simply tells you that the dump site has not gotten a significant impact to the groundwater in the Keaton dump site. This might be due that the dump site in the Keaton area is downstream, while the wells are upstream. So this is one of the research paper done for this particular objective. So let's go to this another paper done for this objective. So the other objective is to determine the origin of groundwater and dissolved iron in the Grammy and the Keaton dump site. Here you find out that this is the global meteoric water line, and this is the precipitation line. So all the samples that falls within this global meteoric water line are in fact to have come from precipitation. So in that case, 78% of the precipitation plot on the global meteoric waterline, which suggests insignificant evaporation. However, we find out that for the Gravity Group alongside groundwater, the majority of the samples fall within the global meteoric and the precipitation waterline. That simply tells you that the majority of the water comes from precipitation. Even though some deviate from it that are found upwards from the global meteoric waterline, this simply implies that some of them have been impacted by anthropogenic pollution. This could be dump site leachate or septic waste due to methanogenesis, which I earlier discussed. When you look at the Kington dump sites, which are the green, the majority of them also fall within the global meteoric waterline except for 2 samples. So these ones are 100% from the precipitation without undergoing any secondary evaporation process. Whilst these 2 have been impacted by either domestic wastewater or dump site leachate. So in general, the origin of the groundwater is being obtained from precipitation. So this is the origin of the dissolved ions. Here are 3 types of water we have eliminated. Everything is adjustment. Anyway, so this is. So now I have determined the origin of the groundwater. So after I determine the origin of the groundwater, I try to see how best it could also be determined quantitatively. So in that case, after working on the Bayesian isotope mixing model, I found out that 96.5% of the water, of the groundwater in the study areas were recharged by precipitation, while only 3.5% were recharged by seawater. So this is also to determine the origin of groundwater and dissolved ion. This is the source of the dissolved ion. From the Bayesian isotope mixing model, I found out that 44.7% of the water were not by any way affected by the dissolved ion. That is why it is regarded as precipitation. Whilst the seawater, 7% of the seawater affected the groundwater, induced the dissolved ion in the groundwater of the Gravity Group dump site. Here, 33.0% of the leachate induced the dissolved ion in the Gravity Group dump site. Whilst for here, 15.2% of the domestic wastewater induced the dissolved ion in the Gravity Group dump site. For the Kington dump site, 58.5% were not by any way affected by the dissolved ion, while 7% induced the dissolved ion, 21.5% of the leachate induced the dissolved ion in the Kington dump site, and 13.0% induced the dissolved ion of domestic wastewater induced the dissolved ion in the Kington dump site. This is the paper published for this particular objective. Result and discussion for objective B, that is to determine the sources of the nitrates. Here, this is what we regard as the Kendall diagram, which will like actually demarcate the specific areas of the nitrates and the other processes. So you could see that the majority, that is 75% of the groundwater in the Gravity Group dump site, the purple color, fall within the manure and sewage zone, that is the desertification zone, while it's only 25% fall within the organic nitrogen zone. For the Kington dump site, which is designated as yellow, 80% of the values of the point fall within the manure and sewage zone, while 20% just fall within the soil organic nitrogen zone. This simply gives a demonstration that the majority of the sample were affected, the nitrates sample were affected by the manure and sewage zone, coupled with the soil organic nitrogen. So this is just a qualitative overview. For the quantitative overview from the SEMA model, I found out that 3.3% of the nitrates in the Gravity Group dump site emerged from atmospheric deposition, whilst for the 3.6% emerged from soil organic nitrogen, and 5.1% of the nitrogen fertilizer induced the nitrates in the groundwater of the Gravity Group dump site. 31.0% of the manure and leachate induced the nitrates in the groundwater of the Gravity Group dump site, and 70% were only affected by the domestic wastewater. For the Kington dump site, 32.2% of the manure and leachate is postulated to have impacted the nitrate concentration in the groundwater of the Kington dump site. So, notwithstanding, however, it could be very difficult to use. It could be very difficult to use the N15 and just the O18 to determine the precise sources of the collision, taking into consideration their overlapping ranges. So what I did was I utilized dissolved oxygen, because you know dissolved oxygen could be used to decipher the difference between denatrification and ammonia volatilization, as I elucidated earlier. So when I used the N15 and dissolved oxygen in my model, I detected that 23.8% of the soil organic nitrogen contributed the nitrate to that of the water in the granular dioxide. 61.1% of the nitrate in the granular dioxide was impacted by the manure and leachate, and 51.1% of the domestic wastewater impacted the nitrate concentration in the granular dioxide. For the ketone dioxide, 29.1% of the soil organic nitrogen induced the nitrate concentration in the ketone dioxide, while 55.0% have the most significant impact to the groundwater nitrate in the ketone dioxide, and manure and leachate have 15.9% impact. This particular result demonstrated that the downfield pricing has a significant impact to these values. Here in the ketone dioxide, the reason why the manure and sewage have the least impact is because the dump site is located downstream to the wells, whilst the wells containers are upstream. So there is no way that the leachate will move and contaminate the groundwater. But whilst for here, in the ketone dioxide, the wells are downstream to the dump site, meaning the dump sites are upgraded. So this particular paper is currently under review. Conclusion. So almost all the groundwater at the ketone dioxide are suitable for drinking purposes, whilst the majority of the wells at the granular dioxide were unsuitable for human consumption, more than 50%. Also, with regards to the heavy metals contamination, 41.6% of the groundwater in the granular dioxide are highly polluted by heavy metals, whilst for the ketone dioxide there was no impact of the heavy metals to the groundwater. The majority of the groundwater in the study areas are of meteoric origin, that is therefore precipitation. Also, 96.5% of the groundwater were recharged by precipitation according to the SEMA model, whilst 3.5% originated from surface water. Moreover, the majority of the groundwaters in the granular dioxide were bleached by leachate and domestic wastewater. The nitrate in the study area was mainly for manure and leachate and demonstrated in the byproduct of the N15 and the O18, soil organic nitrogen and domestic wastewater. The SEMA output, which is the N15 and dissolved oxygen, demonstrated that manure and leachate had the highest contribution of nitrate at the granular dioxide, while the domestic wastewater contributed the highest nitrate to the groundwater in the ketone dioxide. So what are my recommendations? 1. Additional traces such as the boron, the tritium, and the carbon-13 must be employed to further delineate the different biochemical processes taking place in the study areas. Also, N15 and dissolved oxygen concentration have proven to be effective in delineating differences between ammonia volatilization and denitrification of other biogeochemical processes. So hence, it must be used. And engineered landfills must be built on the dump site this site is far away from the city. Responsible stakeholders should also enforce regulative measures before boreholes and handheld wells are cited by private individuals. The other responsible stakeholders should also try to develop strategies to control and mitigate the occurrences of major and trace metals in the study areas. This is the contribution to my study. The study confirms the viability or the feasibility of using the SEMA model to quantify the origin of groundwater recharge, dissolved iron and nitrate sources. So this will be very useful or serve as a baseline for any isotope studies in groundwater globally. So these are the limitations. One of the limitations that I recall during the research was that there was lack of detailed geochemistry data in these specific study areas. Also, there was inadequate funds to conduct all the necessary isotope analysis, such as the boron, the carbon, and the tritium. Because this boron isotope will be very good to differentiate between the animal manure and other sources of manure, like for instance, hog manure, cow manure, and different sources of manure. So also, few boreholes and handheld wells they are utilized. That is, there was insufficient sample size. So it actually affected my multivariate statistical analysis. So these are selected list of my references. Acknowledgement. I want to first of all give thanks to my supervisors, such as Engineer Professor Lala Safidechi, Dr. Mrs. Sitiala, and Professor Fraser Williams. Even despite their tight schedule, they were able to read through my work and prefer constructive criticisms. I appreciate you. I also want to give thanks to the World Bank and Engineer Professor and to the officer for the scholarship offered to undertake this program. If not for this scholarship, I would have been here to be talking to you guys. I also want to give thanks to my honorable Professor John K. Owono, Dean of Graduate School. I remember when he first gave his lecture during the research seminar. His lecture actually helped out in shaping my work and my objectives. I appreciate you, sir. I also want to give a round of applause to the most critical professor I have seen. That is Dr. Prince Anthony Adeyi, who is the head of the Civil and Environmental Engineering. I remember the first time I did my project proposal, I was discussing byplots. Then I was referring to that byplot as multivariate. He said, no, you are wrong. I tried to argue, I said, no. So I went and read, I said, he was right. So today, at least, I had a paper on multivariate statistical techniques. I want to also thank you all for coming. And rest in peace to my brother who just passed away 3 weeks ago in Ghana. Thank you.
Let's give a clap to brother. Great. So Abdul, Aziz, SANKOH. Great. So you have done the presentation. It's time for you to be examined on the work that you have done. I can see that you have done a great job. You have veered a bit into my area, the multivariate. Please note about that. So checking the multivariate part to see whether everything was okay. But I know that the examiners have checked that, and then we'll see how it looks like. So you will know Dr. Emahi is online. Dr. Emahi, when you come back from Cambridge, you come and see me. I have a small fight with you.
Please.
Yes, so when you come and see me. We'll give you the chance quickly to examine because we may not know when the internet will go off. So just examine the candidate briefly, and then we'll allow our big examiners here, Professor Kingsford Adabo and Dr. Tay, to examine the candidate fully. So we can start with you, please.
All right, thank you, Prof. Good job done, this is a case, but the methods was in I commend you for the webinar. I do have one question and a suggestion. So I know you made some very good recommendations about stopping citing these mercury plants and stuff like that to prevent the diffusion of nitrates in the water bodies. And as a PhD, well, you are getting a PhD degree, that's a lot. And you are started to contribute a lot to the society. My question for you is that because I know there are ways to actually remove nitrates from water. So in addition to your suggestion of the combinations that you made, do you have any way you could also advise maybe business of this water to remove the nitrate from the water before consumption? Do you have any idea?
Yes, we can use the nitrification method. That is using microbacteria or microorganisms to remove the nitrate. So
can you explain how that will be done? Explain that to the common lay person who wants to use the water for their domestic consumption. How is it?
So we are going to have what we call a slug, and we place microorganisms. We have the water on the wells, and we place the microorganisms in it, and the microorganisms will convert all of the nitrates to consume the nitrate to all of the oxygen in the nitrate and convert them to nitrogen. So it has to be within a confined space where there is no oxygen, so that at least the microbacteria will be able to utilize the oxygen in the nitrate and convert them to nitrogen. So by so doing, the nitrate will be reduced from the water body. So that process will be referred to as denitrification method.
But why couldn't you include that as one of your objectives, just to see if it would work for
Yes,
this
so,
one?
so I will include it, sir. Thank you so much. That's a very brilliant idea.
No, you will include it. I thought you are done with the work. How will you?
No, but I am going to do some corrections and later please
Okay, all right, that's fine.
That's what I mean.
Okay, then that's fine. While you are doing the corrections, also I think I mentioned it in your thesis. So, you know, I'm a chemist, so I do care about the way you write your chemical formula. So on your slide 25, I make sure you correct the way you wrote the formula for nitrate and ammonia. So you should write them correctly. So slide 25, I think that's enough. Yes, this one. So in your figure, you can see how you can put the nitrate and ammonia the light. So just connect them.
That one is because of the Excel, so it could be difficult to use the equation. Yeah. So that is why you find out that the sources of, when you look at AOC, the nitrate was well written. But over here, it could be difficult to use the equation method in the Excel. You can use the Excel, but I will find a way to. I'll find a way to work on it.
Okay, all right. That's nice.
The software. I think I have.
Yeah, I think you should be able to do that. Yeah. All right. Thank you so much.
Okay. So continue the examination with. So I believe you are still there. Hello?
Yes, I'm here.
Okay.
I'm here with you.
Okay, so we are proceeding with the examination. And we'll continue with Professor Kingsford Adabo in that regard. So we'll give the floor to Professor.
Right.
Yeah.
SANKOH at AZIZ.
Yes,
Right. So that's a good presentation.
Okay. So Prof said that is a very good presentation.
Good presentation. Anyway, in our principle somewhere else, the dean don't have to say things that as if we have already we have not passed yet. So,
I don't know what I said.
Don't say very good and all that. It is asked to say that.
I didn't say it.
I have not passed yet. I have to be examined.
Did I say something?
Sample.
I forgot.
I think it's a good presentation. Even though your tempo, I'm sure because of the number of slides, where your speed was also the you have to go down so that you can make your points very clear. Can I see the first one? The very first slide. Okay. So, Mr. Aziz, what after this, until I get your PhD, what do you call yourself? What area of scientist do you call yourself?
So
Are you an engineer, civil, what area? Environmental scientist? What area would you call yourself?
probably environmental engineer or environmental.
You shouldn't be proud. You should be able to know. Of course, I know there is always a hard explanation, and you should tell yourself, I am AZIZ. After this, I am this specialty. What is your specialty?
I'm an environmental engineer. I will be an environmental engineer.
Right, AZIZ. When I look at some of the things, the thesis and the oral presentation. I am happy when the other supervisors said, or examiners said, that we have not done, we are still to do certain things. So that's fair. And as I see some areas of the use of symbols and then acronyms, which I think will be problematic. I added them in my when I said, I don't know whether it's not that is explaining what I'm seeing because it's being repeated. I know that possibly elsewhere in the literature, because of the itself that I have issues because there are a lot of chemistry involved, let's say chemistry. Then we also have some other, so many symbols like for I don't see the go for carbon, and because we are doing environmental things and elemental analysis, so when you want to do the CD as for the documentation for the deviated quantification. So even though you might have seen it also as maybe the papers, the pure chemistry paper, you have to have it. So I I think just what is the goal? Just the goal.
Or the goal. Okay, the goal of the work basically is to determine the collision sources of groundwater within the study areas, which is the garbage we can keep on dump site. Because within the dump site, we have different polluting sources. Let me just show you. We have different polluting sources. That is the pit latrine, the seepage, the runoff from pig manures and the like. So, we've asked the government to actually relocate the dump site because we postulated that the dump site has been polluting water because in 2015 we had a cholera outbreak from the dump site. But then we are objecting that do you have the data to actually prove that the dump site is polluting water because we have several other sources of pollution within the study areas. So what I try to do is to determine the sources of those pollution and even to quantify them. That okay, if dump site is polluting water, how much of it is polluting water? So I believe with this data, they will be able to know what to do. Yes, policy making. Yes, so that's the goal.
So you know that these rates that you have done, they are not some of them are they are people have done the environmental analysis, I want to ask about the uniqueness of work. Can you just listen to the and then
One of those online today.
but if you hear me ask you before you so if you hear that is fine.
All right.
So don't bother about it. I just want to know, take note of the uniqueness. Knowledge, we are trying to bridge some knowledge gap. So how do we distinct this? That is right. So you look at people have done environmental analysis, concentrations, the chemistries involved. And then you come in with this isotopic aspect to be able to look at the origin sources of these information, which are the now, with the isotopes, I would want to ask you, looking at the isotopic is that if you have isotope hydrogen, oxygen, nitrogen, etc., name me the available isotopes of hydrogen, of oxygen, of nitrogen.
Okay. First of all, the available isotope of hydrogen is first of all the proton, the deuterium, and the tritium. So the proton and the deuterium are the stable ones, whilst the tritium is the radioactive one, the unstable one which will decay in time. Even the tritium will also be used in groundwater storage. Whilst for the oxygen 80, we have the 16, we have the 17, and we have the 18. So those are the isotopes of oxygen, and those are the isotopes of hydrogen. Or nitrogen. We have the N15, we have the N14, yeah, we have the N14 and the N15.
Right. So as if you look at these isotopes, which are very instrumental in tracing the sources and origin of this pollution. You did in your earlier submission, you told us what isotopes are in terms of the different processes. Will you say that the chemistries of a particular isotope, say deuterium, or the lighter form of hydrogen, their chemistries will be the same or different? If yes, why? If no, why?
Okay, so the chemistry should be different, owing to their different masses. Are you talking about the isotope? Are you referring to
Talking about their, when I talk about their chemistries, I'm trying to talk more in terms of their chemical reactions. Chemical reactions are like this. Atom entities, their chemical reactions. So we say the isotope is deuterium, for example, and then okay, let's say 2H and then 1H.
Yeah.
You have the same chemical reaction, fingerprints, etc. Or you expect them to have the same chemical.
Oh, okay, awesome. So first of all,
Whatever it is,
so first of all, for the isotopic point of view, we are not looking at the chemical concentration of the hydrogen and the chemical concentration of the deuterium and the proton. We are looking at the ratio of the deuterium over the ratio of the proton. So that ratio.
So, thank you. So I'm just asking, I'm trying to ask you indirectly, what actually code for the chemical activities of atoms? If you look at the structure, also should be aware of looking at atoms. What are the components of atom that atoms is responsible for chemical? That's simple.
All right. For me, it's the atomic number. No, the proton numbers. Yeah. So when you look at electronic configuration, right? If we have, for instance, when the orbitals are like completely filled, right? So if let's say you have the first orbital, which has the tendency to take like the maximum of 2 electrons, and it is completely filled like the helium, there is no way that helium will be regarded as a noble gas. There is no way it will undergo any further chemical reaction. But when you look at, let's say, for instance, sodium, which is like 2H1, that one is the outer electron. It is not completely filled. So because it is not completely filled, it has to either lose or gain electron for it to become stable. So in that case, because sodium is a metal, it has to lose electron to become stable. Yes, policy right. Yes. So if you're talking about the electronic configuration, it's also related to the proton as well. So that those electrons around the electronic configuration are also regarded as the protons.
So should I be asking that? I'll ask you. If you look at the structure of a typical atom,
Yes.
which part of it is actually the most
Is the electron. Yeah, it's the electron.
Right. Now go to the next slide. Okay, stay there. So you did mention types of isotopes of particular atom. So we have the lighter nuclei, We are using the heavier nucleus of this part.
Both the heavier and the lighter.
Yes,
That's
when
what
you do the proportion.
Yeah.
But for the purposes of looking at the trajectory or the origin, the emphasis is more on the heavier, right?
Yes.
So I'm asking you, what actually makes the heavier ones the ones that are useful for tracing the origins and not the lighter?
All right. So it all depends. It all depends as well to the type of transformation we undergo. You know, we have evaporation, that is the conversion of liquid to gas. We have condensation, the conversion of gas to liquid. So in that case, if evaporation occurs, that is the conversion of liquid to gas, definitely the oxygen, the deuterium, that is the heavier element, is going to be highly enriched.
Sorry, that's the next slide. The next slide. I think this is better. I looked at an equation which, especially that is vectorization. So, because at a point, I did not see the equation being but the first part, that's the amendment.
Yeah.
The paper for, I think that, I saw it somewhere in the team.
All right. So let's say go to
Right. I'm going to ask you, if you sit back after doing this, before and after, if you sit back in this way, in this receptor,
yes.
before and then after, what will you say before you started? Were there limitations that you were fearing to encounter before the start of this one? Then after the experiment or the project, what limitations do you say you feel that they are still existing? And that is, what flaws do you think are still part of this one that might have compromised some of the results? Right?
Yeah. Please a little bit.
Sorry. I'm trying to ask that, you know, tell you something. These days, when you publish a paper, when you have done and you have done a paper, when you publish it, there is a problem that you ask, what are the limitations to the work you've done? Normally, we are not happy when you ask this. It's like you're expressing your own. Then perhaps you yourself will say to me, other people to carry on and you can see how you can make it better. And then when you're able to answer that, I'll have a few of this. What do you think? Where or are the limitations in this one? I saw some that
I want the limitation is funding. Like for instance, abnormal circumstances. Because I love doing Now, when you look at my second this, right? My first is this limitation is funding, because if I had gotten enough funding, I could have done boron isotopic analysis, carbon-13, and tritium. This tritium could also be used to determine the specific sources of the leachate, whether it's coming from. Now, from my study, I cannot be able to differentiate between septic leachate and that of dump-site leachate. The only thing that will be used to do that is the tritium analysis. So if you could go through my research, my review paper, I highlighted it. But there was no fault. Also, the boron 13, it could boron 11, sorry, or 13, it could be used to differentiate also between, because when we say animal manure, it is a general term. So it could be used to differentiate between the hog manure, the cow manure, the sheep manure, and different types of manure. So if I got enough fund as well, I could have further worked on this. With regards to the sample size, which affected me in my multivariate statistical analysis, I am very much conscious of that. That it affected.
So,
I pull out.
because then that is where I'm coming to.
Yes.
So, the sample size, I saw that, and it was part of it, like you said, that
Yeah.
we are taking two particular areas, the Kingston
And the Gambia.
so you are limited to sample. But then I saw that you take this is you take a lot of holistic analysis of other things to make. I'm just giving the question that I'm looking at, that to make it possible to have a lot of data in a smaller sample size, where else it is account. So I think that was one limitation because we faced, but we tried to make amends to I saw a lot of things.
Yeah. So with regards to that funding, so some of the sums that we are giving to me, I even had to build boreholes. I even had to build wells in the gravel book. I wasn't having enough fund again to build wells within the Kingston. So I had to use the existing one. So funding is difficult. And even this my research paper, as I'm telling you right, this paper, right, after their first review, this from Science of the Total Environment, they set it back. They said I have to add recent papers for 2023. And when you look at the internet for those recent papers, they will cost 34 euros and stuff like that. So that is also funding. So if I had gotten the money, I would have paid, right? And so I had to send it to Chemosphere. So them two, I believe, probably. I mean, you will ask me to add something.
Your library, are you not meant to use when you have some literature?
We have, maybe it's not available. We have the ourselves. We are linked with a page.
So that you don't have. When you talk, because I've also seen you as an environmental engineer. Yeah. So as an engineer, we are looking at things that as a policy to be able to keep the stakeholders to be able to help. You mentioned maybe one of the things to do is relocate these people somewhere else. Okay? And relocate them somewhere else. I was hoping that when it was possible, if as part of the work, you are taking the best eye view, because it's a small locality, maybe not maybe more than 2,000 hectares. So we are taking the best eye view of how the settlement. Well, I'm thinking about the bush. I don't know about the bush. Have you heard about the bush? No. Oh,
No, me, I'm in Sierra Leone.
yeah, I know. You have been here for some time now. So when you're doing this kind of work, you should also know what is the current thing about the bush. You ask yourself, tell me, certain issue.
That's what I was doing. Downside.
So where the vaccine of this current issues. So either you locate the people or you locate the problem. Environmental engineer, and I was surprised that initially we were not talking about the kind of, the land where they are now dumping, they're just dumping.
Yes.
But this problem could have, if you can tell the people who are
type of, bottle, sampling bottles used, like you have mentioned one, polyester, polythene.
Polyethylene.
Yes.
That's
yes.
only one type of it.
Good. Now, what sampling bottle did you use, for instance, in the collection of samples for stable isotopes?
Same polyethylene, high density polyethylene bottles. But the difference is I use the 30 ml this time around rather than the 500.
I'm interested in the volume.
Yeah.
Did you use plastic or glass bottles?
I use plastic, the polyethylene bottle, the high density polyethylene bottle.
For stable isotopes, I think we use glass bottles. And the glass bottles must be the white glass bottles. You can check. If you are going to collect samples for stable isotopes, you don't have to collect them in the plastic bottles. You must use glass bottles that are actually transparent. Are you getting it? So I need to see all these in your the methodology.
Okay.
You get it?
So let me ask you whether the sampling of the guide, whether you want
The analysis. So I think it's good.
yes,
But
they were
They would have done that. So you see, you should have told me exactly that you were not involved in the collection of samples.
no, I collected the sample
You collected samples from free
from Sierra Leone
and brought them to guide for them
Yes.
to analyze.
They did the analysis.
Okay.
Yeah. I
but
collected.
you should have been there to see it and explain it. So maybe you gave it to them and sometimes you do these processes and you don't know what they are. But you have known the cycle, what all that they are.
Yes.
Set
Cynthia actually proposed that was.
So then, I know you did the right thing. I'm not saying you did the right thing, but you did the right thing yourself doing that you're doing the right thing.
I collected the sample, but I also learned the process from there. But I did not do the analysis because I'm not working. But I made sure I was there myself to just see how the process looked like.
Okay. Now, I also want to see in your method how the samples were preserved prior to delivery to the laboratory, as to whether you just put them in the car or you put them in an ice chest filled with ice and all that. It's not in your thesis. Yeah, so all these things I'm talking about, just take note of them and clearly spell them out in your thesis. Right? Now, I have a huge problem with your sample IDs. As I sit here, I do not know exactly the number of boreholes. I didn't work on boreholes in wells.
Yes.
You kept saying groundwater, 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 groundwater. Now you say groundwater, I don't know which sample ID is for groundwater and which one is for well water. And so that is it's a whole confusion in your thesis. So I think that you have to now sit down and tell us exactly the IDs for groundwater. Sorry, for borehole are those that are wells, so that we know clearly that this ID is well and the other one is groundwater. Good. Now let's come to the streams. Did you sample? No, you also refer to some of the samples as surface water. I don't know whether they are rivers, streams, lagoons, or whatever, or lakes. That one must come out clearly. You were referring to surface water, surface water. So did you sample river or did you sample river?
I sampled like a stream.
A stream. And what else?
So the surface water, I sampled the stream, and also those domestic wastewater, some of them I refer to them as surface water.
Domestic wastewater.
Let me just show.
No.
Okay. No, sorry. So this surface water, that is from the stream. So I only took like 3 or 4 samples.
No, I don't know of domestic wastewater as surface water. Maybe
The domestic wastewater is this one. The wastewater here.
Yes,
Which is
so
also
refer to
in
that one as wastewater.
Yes.
Refer to domestic, the leachate samples as leachate samples.
Yes.
We know surface waters are clearly stated.
Yeah.
Lagoons, streams,
Yeah.
rivers, lakes, and all that. Springs and all that. You get that one?
Yeah.
So please take the wastewater out and take the leachate water out. Now, how many leachate waters did you sample?
Like 4.
I saw 2 from the table in your thesis.
Yeah, I think it's 2.
I saw only 2, not 4.
Yeah.
I saw 2 leachate samples and I saw 4 wastewater. But I had to even struggle to be able to bring them out. Now, why did you sample only 2 leachate samples?
Because for the leachate analysis, you have to do isotope analysis of it. And the isotope analysis is extremely costly because I have to do the theorem and observability. I also have to do the N15 and the probability. Those ones can cost up to 1,000.
We have more leachate samples in the area.
Yes, we have.
We have more leachate points in the area.
Yes.
You could have sampled the other leachate points just for the feedback analysis, so that we can see the impact of the leachate on groundwater. Now, my problem here is with the using very small data for BCA, multivariate analysis.
Yeah.
It's been established. Let me read to you here.
Yeah.
That the sample size is too small for BCA. Why? Because a minimum sample size ranging between 40 and 50 has been established to be sufficient in ecological and environmental studies to recover the first few components that are necessary to explore, comprehend, and summarize the multivariate data. Now, the 40 and between 40 and 50 data points, it is not you going to the field and identifying only 2 boreholes and coming here by now going to take one sample today, another time you go and take another sample, another time you go and take another sample, and making it up to 50 or 40, between 50 or 40. It has to do with different data points. Are you getting the whole thing? Yeah. It has to do with the different data points that together will give you a minimum of between 40 and 50. So honestly, my problem with the word, this is an excellent word, if you ask me. But my problem with this word is that you try to make the data points big. In fact, you stated here that you have about 60 data points.
Yes, because I sample for both the dry and the rainy season.
It doesn't matter. It is the same data points you are taking your samples.
Yeah.
What I read to you refers to different data points that you take. It is not, like I said, otherwise, scientists, we can just identify one borehole and we decide to take one borehole about 100 times and say we have 100 data points to write a paper. If you are supposed to be reviewing that paper, will you pass it?
Yes, with regards to that as well.
Say again?
I said with regards to that as well,
Yes.
we have some other literature and also prefer that the KMO, because we look at the KMO value,
Yeah.
which is the Kaiser something value.
Yeah.
AMO values are very low. I've seen it.
Yeah, it's like when
It
it's
should be about 0.8 above. We have 0.65.
okay.
I checked already, so
Yes.
I didn't want to come in because I'm not
So
understanding.
there was a
So-
literature I read that says that the KMO
So
value,
both your KMO value and the balanced test of seriousness are too low. They are around 0.6. And then you have a sample size, but you have a lot of variables. And then the sample size should be at least 5 times the number of variables. You have a whole list of variables. And that's why, but let's just
because the problem is the font, especially.
No,
it's
we
not about
understand.
the
We
nice,
understand.
It's about.
We understand, but you have to
thinking
understand
the
that
words.
this is a limitation of
Yeah, that is why I started
of that portion of the work.
Yeah.
I mean,
I started
that
with
portion.
words.
Particular data point, that was in the looking at the west season, that season.
Yes. Yes, what I have noticed is that because you have few data points, you try to make good use.
That's why I stated it.
Yes.
And then when you were looking at the number of components extracted,
Yeah.
you limited your discussion to 2 factors and talking about the first 2, explaining the 69% of the variation. But you have 4, you have done a split block of 4.
Yes.
So the other one has 5 components. The second one, the other dam side have 5 components.
Yeah.
And you are limiting yourself to only the 2.
I discussed all of it.
No, I saw it. I just checked. So you don't worry. Later on you can do that correction. So if you are talking about the eigen values, okay, they're using the eigen values to explain the number of the variations, the percent of variations, those components that you have extracted, I've explained. And also, I didn't see you giving names to those components.
Yeah.
But I think it's with our examiners here.
So in that
I didn't want to come in.
in that component case,
Because it has come to my area, so I have to.
in that component case, I use the eigen value to extract the components, and I discuss all of the components. If I'm having 4 components for the AABDUL site, I'm 100% sure that we have discussed it. The only thing is
You mentioned only two of the first two important components for each of the dam sites. Having said that, they have explained, this one explains 69.something%, this one explains
Yes, because I just wanted to explain that diagram,
Okay.
the components and diagram, the blue diagram.
Okay.
Because that blue diagram cannot take more than 2 components. So that's what I wanted to just explain.
Okay.
But when you look at the table, I explained the different components
Okay.
within that table. But that diagram cannot accommodate more than 2 components. I don't know whether
And it's okay.
Yeah.
Aziz, Senior, please. Okay.
Aziz.
I'm just contributing to the discussion.
Very small data. Magnify your discussions when it came to the bivariate plots. You know, in a bivariate plot, the R squared value is very important. Agree? In any bivariate plot, and the R squared value is very important, right?
Yeah.
What will be the least percentage of an R squared that will make you think that the graph is a good one?
At least 90%.
At least 90%. So if you have an R square of 0.0003 or 0.0028, and you are using that one for your discussion,
For which plot?
there are a lot of plots in your
Yes. With regards to that, I was just like, for instance, let me just go to my supplementary file. Let me just clarify this. So when you look at this case, so here I was trying to demonstrate the relationship between the bicarbonate and the N15 to just show how denitrification has probably affected the groundwater in this case. So here we found out that the relationship between this bicarbonate and the N15 is like they are correlated by 0.31. That's 0.1%.
0.31. And you say
31%. 0.31. So that simply tells, so this is like not trying to compare to find the R square of this, but it was just trying to demonstrate how many wells actually correlated with the bicarbonate and the N15 to actually decipher the process that are occurring here.
Yes, if you ask me, this graph that you have projected, it tells you that the relationship between the N15 and what? The bicarbonate is just about 31%.
Yeah.
So you cannot use it to tell me that the process, is going on in groundwater between the nitrogen 15 and bicarbonate is major. You cannot. Statistically, you cannot.
Okay.
Agree? And so when I saw, in fact, the most of it, even to the extent that you were trying to justify the processes taking place in groundwater using an R squared value of 0.0028.
I think I see that one as the root mean square error of approximation.
Value to determine all the graphs you have told us about that. Oh, there is a correlation between nitrogen 15 and bicarbonate just because it's
That is not correct.
correct.
The percent,
Yes, it's not correct.
of variation.
Now, you also talked about sampling soil.
Yeah, the soil sample.
Yes, you did not report it in the thesis. I didn't see any data on soil.
Yes.
Why?
Because I have the data. I actually thought that
If you have the data, I did not see it. I haven't seen any data. You are even talking about soil. Yes. Yes. You're talking about soil data and all that. I didn't see any soil data on any of your thesis. And I'm like, wow. He's talking about soil, yet never there's no data here. You have it. I don't have it.
you're right. So right to me in the supplementary. So I'm going to
Appendix, in fact,
the appendix.
what I want you to do is to go back and take and draw separate data for all the environmental, what is it called, samples that you have taken.
Okay.
Separate data for them.
All right.
And you can have that one as appendix.
Okay.
Instead of lumping everything together and all that, trying to, Yeah, so these are the things I think you need to do. Any other? Now, You said the calibration of, if you calibrate instruments in the lab regularly, it is to have correct values.
Yes.
Correct values?
Well, it's to have a consistent value.
No, not consistent values, not correct values. Maybe
Precision and
Yes.
accuracy.
Yes.
You know the difference?
Yeah, I know precision and accuracy.
yes. So
They're not the same.
Yes, so for accuracy, it is when something like you are very, first of all, you are very close to the true value. That is the accuracy. Whilst precision, different values is bunched in one place, but they might not be accurate. So that's precision.
yes. So I want you to go and correct that.
Alright.
The calibration of instruments in the lab is meant perfectly to eliminate analytical error. Of course, it will come back to getting correct values, but the primary aim is to make sure that you eliminate analytical error, right?
Yes.
Then he also said that you purge the groundwater for 5 minutes to ensure that you collect fresh samples for analysis. In the key again, I found that it was fresh samples. Are you purging the boreholes for sampling because you want fresh samples?
Yes, because the thing is,
Perhaps it is the words you are not using.
okay.
We purge the boreholes for 5 minutes in order for us to take representative samples.
Yes.
Yes. Because if the groundwater is there for months and it has not been used before, you want to go and take the borehole, your sample from that borehole to go and analyze. And you just pump, and then within the first 2 minutes, you take the sample. It might be stagnant water in at the surface of the borehole. But after having pumped for a long time, the reason why perhaps if I go to sample a groundwater, for instance, in a community where the people have used it, the whole morning, when I go there, all I need to do is to make sure my bottle is clean and all that. I use part of the, I pump some of the water into my sampling bottle, rinse it, pour it back, and then, take a sample without purging. That is because the borehole has been in use the whole day. You understand it? So whatever sample I take at that moment will be representative of the sample. So please, these are the things you need to correct.
All right.
Then, for instance, the sampling, you said you sampled surface water.
Yeah.
That's a stream, right?
Yeah.
How did you collect the samples?
So I was in the boat, then I used the deep sampler.
Deep sample.
Yeah, because
How?
the deep sampler was from Friday, so it's like automatic.
Okay.
Dip it down, you know I put it into the subsurface.
About how many distance from the surface?
Yeah, 1 to 3. So it's not like, it's just like an approximate. Because the deep sampler itself is like 6 feet. Yeah, so if you know right, the one that is left up was like just 3 feet. So I just estimated to be 1 to 3 feet. Yeah, 3 to 4 feet, sorry. 3 to 4 feet, yeah.
It is not in your thesis. You have it. I don't have it.
Okay, I'm going to.
Okay. Now, I saw that. Let's come back to pH. The pH in the area.
Yeah, is it the analysis?
The pH values, the values of pH in the area, or either it was at Granville dam site or at Kingston dam site. We all acidic, agree? Except one that was about, a few of them serving.
So the ones that we are closer to the Granville Brook dump site, some of them, most of them we are basic. The ones that
not most of them, some, a few.
Yes,
Basic.
but for the Kingston dump site, all of them were acidic.
Yes, so that's where I'm going to go. Now, we are dealing with boreholes at Granville Brook, dam sites that are actually downstream. And as against the Kingston dam site, which is upstream. Now, the Kingston dam site has that has all the
The Kington, the dump site of the Kington was downstream.
yes.
The wells were up. Good, shoot.
Exactly.
Whilst for the Granville group,
Yes.
the dump site was downstream and the wells, sorry, the dump site was upstream and the wells was downstream. Yes.
So even before you collect the samples, with this description, were you expecting Kington dam site concentrations of the various parameters to be higher than that of Granville?
I wasn't expecting that.
Yeah.
I wasn't expecting that. Yeah.
So the results that came clearly, it shows clearly that the Granville group dam site has the various parameters higher than that of the Kington,
Yeah.
and we are assigning it to leachates, infiltration, wastewater infiltration, and all that. But you notice that even though the Kington dam site has very little impact from on the groundwaters, you still have the pH very acidic, 4.6, and I think the last one was about 6 or something.
Yes.
So what reason do you assign to the Kington dam site pH?
It's been affected by what you got at the domestic wastewater.
Domestic water?
Yes, the domestic, yes, because within enough sites. So let me just give you an indication of what I'm talking about. Now, when you look at here, the fact they are doing the washing here, and at the same time they subject the same wastewater in very close to the wells. And some of them, when they wash their pants and all that stuff, they subject the wastewater very close to the wells. And some of them they urinate very close to the wells. So when they urinate, we have what we call the ammonia volatilization, those urea and stuff. So that ammonia volatilization will be accompanied by low pH. So in the Kington dam site, we are acidic, probably due to the winds and all that stuff. Right. But while it's for the Granville group dam site, the pH is higher because it has been affected. It is being affected by the dam site leachate, and we know the leachate undergoes what we regard as the methanogenesis.
Are we therefore saying that geogenic or natural processes cannot have impact on pH?
It does have impact on the pH, but when you look at so what I did was I tried to compare the two dam sites, which is the Granville and the Kington, and both of those two dam sites have the same lithologies because they are both made up of the Mesozoic fracture or Triassic igneous rocks. So they would, in terms of no effect to external anthropogenic activities, they both will have the same pH. So in as much as they are supposed to have gotten the same pH, but the pH of the Granville group is more higher than the Kington, that simply tells you that there might have been different processes in the Kington and the Granville group dam site that might have affected the groundwater in the study areas.
Okay. But I still think that the geology of the area could be. I noticed that your bicarbonate concentrations in both Granville and Kington for both dry and wet season. They say, when they say go back to the variation, and I was wondering how come that.
So I did not actually include them here, but I did them in the supplementary.
Okay,
Yeah.
so if you have them there, you can bring them out. Let's see something. Because I didn't understand how come that the special graphs for Granville dam site for bicarbonate for the wet and dry season were the same, and for Kington, wet and dry season they were also the same. I didn't understand.
It might probably be due to the ranges used for the colors, but they are not the same. The bicarbonates, they are higher in the dry season than that of the rainy season.
Right, so please change that.
Okay.
Yeah. Change that.
So I think that's an excellent presentation, and I think maybe for a postdoc you can look at the gaps and things like that.
Yeah.
Thank you very much.
HOD. Yes, Aziz, you are my friend. You want me to ask you a question? My questions won't count, so but I really like your passion in presentation, your zeal. It really shows that you are somebody who is really want to get deeper understanding of things. So I want to commend you to that. I just had one simple question, but then that was what Dr. Tay was asking in his last part. If you go to your conclusion, it seems to be that one we stated it clearly that the drinking water at King Tom. And for your information, I know King Tom and I know the dam sites. Aziz, yes. I'm saying for your information, I know you're Israeli. Yes, I know the dam sites. It's not going. It's not going. So no, the conclusion.
Yes, it's not going. I don't know why. Okay.
Okay. So almost all the groundwater of King Tom dam sites are suitable for human consumption, and that's what
for the pH, I think the
Prof
pH
was saying. Because if you are to use only the water quality index, then it can, because because then at first I wanted to even ask you what informed the selection of the damping sites, because at the beginning you said you postulated that the damping sites are really contributing to the contamination of the groundwater, well, borehole. But at King Tom, your dam site was rather downstream. So which means the leachate and other contaminants wouldn't be able to travel to upstream to contaminate the water. So I was wondering if your concentration was contribution towards pollution of the groundwater, then why choose a dam site which is rather downstream? But how will it?
So, one thing, I try to compare the dam site, I try to compare the two dam sites, because for the King Tom dam site, since it is upstream, so since it is downstream, I know it will not, the leachate will not have much impact. Regarding dam site, since it is upstream, I postulated that the dam site might have an impact. So what I try to do is, I look at the concentrations, the physicochemical concentration of the two dam sites, to know whether, so if both of the concentration will have been the same, I would have inferred that the dam site might not have contaminated the groundwater in the study areas. But what I detected was, I found out that for the bicarbonate in the King Tom dam, in the Grammy Book dam sites, we are extremely high as relative to the King Tom dam site. And that bicarbonate gives an indication of the influence of a leachate. So I was just trying to draw comparison between the Grammy Book dam site, which might have been affected by the dam site because it is upstream, to that of the King Tom, which is downstream.
Your professor will be leaving very soon. Just a second, and what is the main source of water for the people?
Groundwater.
It's groundwater. Because if it were to be something else, I was wondering why the focus would be on groundwater. But if it's groundwater, that's fine. So thank you very much.
Because the surface water it has salinity.
So we have Professor Ronnie Williams.
Yes.
Professor, would like to hear your comments on the presentation. Saw his enthusiasm in the presentation, and he's back. And we want to find out whether or not the AZIZ is actually going to do the experiment again, or take this one home and do major corrections, or some corrections. Examination board, I'll be happy to inform you that the examination board has seen AZIZ thesis as having passed. So let's give him a hand. The panel saw his enthusiasm in the presentation and his responses, and so they have adjudged him as pass, not say anything, just pass. So AZIZ has passed. AZIZ, congratulations. Great. So at least maybe you can sit down for a while. We'll give the opportunity to our external examiners to make further comments on what transpired today, and then we can proceed from there. External examiners are here. Dr. Emani is also online. Oh, he's gone. He's there. For a meeting, okay. So if they made a comment and he's not around, we will proceed that way. So I will invite Dr. Coliste to start with the comments.
And then we will continue this way. We're going to make a great scientist. And so I would urge you to continue in this area. But you have passed. We have to be sure that all the comments as we have given regarding the corrections you have to do, you will have to do the corrections, so that in the end, the work, if it is given to anybody, the person will see that yes, this is a very good work. But as it stands, if you do not do the corrections, then I'm sorry, somebody like me will take the work and say, no, this for me is not it's not a standard work. But I believe that all the different comments from the external examiners and the internal examiners, when captured, the final document will come out very good. Congratulations again. Thank you.
Thank you, Prof.
Congratulations. Today has mentioned there are some questions which is normal. You need to do these corrections. Whether you do them good or not. You know that the system is such that you have supervisors who make sure that people are done in the system. What is our team to have? Who have it off? So try to do it. So they don't for the public consumption. You've done, you've worked hard, and you deserve what you've gotten at this stage. So apart from what they've also said, I think what I will stress will be on the need for you to provide detailed methodology, because most of the questions dwell on that. Your results are influenced, or the strength of your results will be influenced by your methodology. So it doesn't really matter whether maybe you think that with a particular result you want to be silent on it. You provide a detailed methodology, provide the caveats or the limitations towards it, so that when people are also reading meaning into your results and the conclusions, they will now refer to how it was also done, so that it wouldn't be input some kind of misleading or something related to that. So once again, congratulations.
Okay. We'll have a time for some nice photographs outside as a memory of the day of defense of the thesis by AZIZ SANKOH, so that I know that the moment the photos are taken, Facebook, we'll be here and our face will be showing somewhere. Sierra Leone, Instagram, America, Canada, wherever. I know already. So we are going to take that photo for you. Yes. So that before his defense, you know what he did? He said he's taking a transition photo. So he already took one photo with me in the morning. That Prof, I want to take one transition photo. Transition between myself and me. I'm now going to defend. When I'm going to defend, and you also have passed, I'll take correct. So now, let's give a clap to AZIZ again. We'll take a bigger photo. We'll give AZIZ the opportunity to say something to the university community, to the exam. AZIZ.
If you want to. Yes. Thank you all for coming. That's the first thing. And I appreciate all the comments from the examiners. They are well taken note of. And I also want to thank the Dean, one of the most valuable people in my life, because I always speak with him, I always call him, he tolerates me to speak with him and all this stuff. I want to thank him for all his advices and everything. I never regretted coming. He actually forced me to come, but I never regretted coming. I also want to give thanks to the head of department, as I always say, most critical person on earth. I don't really want his question, because his questions are critical, and I appreciate him and all his constructive criticism he has made. And I also wish to thank all my colleagues, Stephanie, Adama, and the likes, for coming and for being into my aid whenever I need something in this university. I also want to thank Mr. Prince, who always disturbs his calls for transcripts and other stuff. You know, it's not easy. When you're out there calling people for certain things, it's so difficult. You know, I also want to express my sincere thanks and appreciation to all the lecturers here in UNER, especially the statistician, Mr. Hadisu, Dr. Hadisu. The R he taught us, the statistics he taught us, that one has actually helped me out into working on the racial isotopics in model. So I really recognize that. I also want to thank my supervisors, especially Professor Dechi and the Iron Lady, Dr. Cynthia La. She was extremely important to me. After I did all my analysis, she said, Aziz, you have to quantify the sources. I said, well, how am I going to do it? She said, read around it. You are going to find a solution. So she always like trying to like make the work, become standard. I also want to thank Professor Fraser and Fraser Williams. He provided the majority of the equipment that I used back home in Sierra Leone, and he was very helpful to me. He gave me the opportunity to lecture in Sierra Leone. He was the first person to give me the opportunity to lecture chemistry back home. I also want to thank him for that. At least that has actually helped in shaping my confidence and answer some of the chemistry questions you've been asking. Yes. I also want to thank my elder brother. I brought him all the way from Sierra Leone just to study at CUCG. He's more than 40 years. I said, no, you have to get yourself educated. So he's currently in the final year now at CUCG. Yes, College of University of Ghana. The College of Catholic University College of Ghana.
Yes, the one here.
Yes.
Correct.
Yes. So he's now in the final year. He's doing human resource. No sooner than he finished, I will let him do masters. But I don't think he's going to be PhD from what he has seen. From what he has seen. So I also want to thank my Sierra Leonean colleagues who also came through to ensure that this place is full of, up to 20 people. Otherwise,
a lot more online.
Otherwise the process will not have taken place. I want to thank everybody for like being so instrumental in my life, my family members, my wife, my sisters. The examiners we are the first people I thank.
Oh, is that? I didn't hear that.
Oh, yeah, they were the first people I thank. The examiners.
I didn't hear.
You didn't hear? Oh, right? Am I right? Yes. Yeah, they were the first people I thank.
Thank them again, let's hear.
Oh, in fact, I want to thank the examiners, the professor and the doctor, for their instrumental and constructive criticism.
And the one
I appreciate.
Dr. Imai.
Yes, Dr. Imai, of course, Dr. Imai, he lectured me, and the same thing he lectured us during my first year in the PhD. That's the same question he asked me. So I tried to demonstrate to him that I still remember what he taught me. Yes, and this water quality index, he was the first person that let me read the water quality index, because he gave us a presentation on water quality. By then I was in the US. So when I came back, I had to join the weekend student. So I met this presentation. I decided to work on water quality index, looked for articles, and did my presentation. So I decided to incorporate this water quality index in my thesis to ensure amenities. Just after 2 months ago, 2 weeks ago, he also instrumental to me. He's there for him to be proud of me. I want to thank my dad. He said, I don't need anything from you. I just want you to have a PhD. I want a son to be called a doctor. I give thanks to him as well. He persuaded me. He's been so instrumental to me. I thank you. I'll set the standard.